So let's say you have a platform that uses microservices. And in this case, we have three services: user service, review service, payment service. When you have clients, let's say you have a web application here. So you have a web client, and you also have a mobile client for this platform, right? So you have your mobile app. Now, if you don't have any component in between these services, it means that the web client would need to make calls to each service in order for it to get the data it needs. Same thing with the mobile app. It makes a call to the payment, makes a call to review service, makes payment to user service in order to get the data it needs, compose that data and display it in the app or in the web client. But this generally creates a problem for you because you are making your clients to do too much work, right? They have to know which service to call, calling multiple services, and then composing the data and displaying it in the client. The common solution to this problem is for you to have a component which sits in between the which sits in between the microservices and the clients, right? So you have a component sitting here, commonly referred to as the API gateway. And what the API gateway does is it takes requests on behalf of these clients and knows which service, right, which backend microservice it needs to call in order to get the data to satisfy the request made by the client, right? So a single call here may require making calls to multiple services, getting the data, composing the response, and sending it to the client. So let's say, for example, we want to view a user profile. And in this app, when you're viewing a user profile, it also shows you the reviews that the user has done, right? So let's just say that's the example. So when you make this request for user public profile, API gateway takes it and it calls the user service to get the user data. It calls the review service to get the review data, composes the response, and then displays it in the app, right? The app now takes that data and displays it. So it makes the request, composes the data, and gives the response. Now, what typically happens is because the web client, you have more space to work with, you may not just show the user profile, right? So you may have the user profile. You may have the user's reviews, right? So you may have a list of the reviews the user has done. But you may also show some other data in the web client. Let's say in this case, we have some tabular data, which comes from some other microservice, for example. Now, what ends up happening is the API gateway will need to say, okay, view user service, right? So if you want to just maybe view a user, right, and then you pass in some kind of ID to view the public profile of a user, this single endpoint has to handle both clients. But because you need more data on the web client, you end up having an endpoint which sends data to the web client, but sends too much data for the mobile app. So the mobile app ends up getting lots of data it doesn't use. It ends up just showing the profile and the reviews instead of the extra data that comes back. So you have an API gateway which gradually over time becomes a bottleneck. It becomes bloated. And making changes ends up becoming difficult because when the web team asks for a request and they need to make a change in the API gateway, they need to make sure that whatever change they're doing doesn't break or harm the mobile app. So you have unnecessary delay because these two clients are now, entangled in the API gateway. Now, this is where the BFF comes in. And what the BFF does is it sits in between the clients and the microservices, but you end up with one BFF per client. So here we have the web BFF, and here we would have the mobile BFF, right? So the BFF for the mobile app does a similar thing, takes requests from the respective clients, and on behalf of these clients, right, it makes necessary calls to the backend services, gets the data, composes a response, and sends it to your respective client. With this pattern, we can make sure that any data that is being sent back as a response to the mobile app only contains the data the mobile app needs. So it's streamlined and you have a better use of your resources. Make a request, ask the respective services, gets the data, composes it, and sends it specifically for the mobile app. For the web, it does the same thing. And since the web consumes more data, it can compose the responses from the microservices in such a way that the web can display that data comfortably. So what happens is that you separated the dependency of these clients on the API gateway. Each client has its own BFF. Ideally, the team that handles the client also handles the mobile BFF. For example, the team that handles web would also be the team that handles the back end for front end for the web. And one thing you need to take note of is you don't want to allow any UI logic to leak into the BFFs. You want to keep this as a back end type of, logic as much as possible. Generally, what they do is make requests to the microservices, get all the data they need, compose a response for that client, and send it back to the client. The client still has to deal with its own UI logic. You don't want UI logic to leak into the BFFs. And the teams that handle the apps or the web also handle the BFF. In some cases, which I have seen, the BFFs are handled by the team that takes care of the backend services. So you may have dedicated teams for this, or one of these teams can take on the BFF. But generally, the pattern requires that you have the client teams handle the logic for the BFF, which also means that they will need to have, skills in writing back-end type of code. If you're using the same language for the back end and the front end, so let's say you're doing, JavaScript here, then that helps, right? So you have some node running for the BFF and then whatever framework you're using for your JavaScript, that also helps. So how is the BFF pattern different from the API gateway? With API gateway, you need to handle multiple clients. But with the BFF, you have a single type of client for each BFF. Mobile BFF for the mobile app, web BFF for the web client. And if you have IoT devices, you could have a BFF for that. If you have other types of third-party clients, you could have BFFs for that as well. But an API gateway handles all clients at once, and you may get like bloated code in your API gateway. This allows you to have separated code, but you need to also take note that you may have duplicated code in the BFFs, right? So you just have more to deal with, more to handle. I've written about the BFF pattern on my blog, and it is one of the most popular articles I have up there. So I hope this short video sheds more light on the pattern. And if there's anything you want to add to this, you can please share it in the comments. Like this video, share this video, subscribe if you found it useful.